Welcome back to A Stellar Insight. Today we are going to talk about time. Time is a very broad and abstract thing to think about, later on attempt to even explain. Many of us do have that illusion that we really know what time, but by the end of this episode, I think you will have gotten an idea that actually there's so much to know about time. For example, you might think that time is simply that thing that ticks away on your watch, or when you turn on your phone and see what time is it for what particular activity you're going to do. But in retrospect, that is actually quite naive and a bit old. So we'll try to go through where time, the concept, comes from, where humanity began to try and understand this very deep and packed concept, then how it evolved to shape our world today. You might even be amazed how this understanding has so much to do with your daily life that you're completely not aware of. Time is so complex. At the back of my head, I have this thought of complexity, and I would say in one form or another that there are multiple ways that something complex can be defined. And there is a very simple idea that of late dropped into my mind, and it's very simple. It says a system's complexity, and in this case we are referring to time, not as one particular entity, but as a system, because time cannot be explained by one thing. First, hear me out. A system's complexity is proportional to the number of fundamentally distinct, non-reducible explanatory frameworks required to fully account for its behavior. There are many ways, and time is one of those things that has a myriad of ways of explaining it or its behavior. And in many cases, each of those is distinct and largely explains an entirely new concept about time itself. So there are many ways anyone can approach this topic of time. And what I seek to do with you today in this episode is to try and look through some of those that have the most compelling evidence, as you'll agree with me as we move along, and see how we can better use them to understand this broad concept of time. So now, first and foremost, let's look back into the past. So with current data that we have about this topic, we believe that the understanding of time starts to show up at 3500 BCE. And this was simply expressed through, this was amongst the society of the Egyptians, the ancient Egyptians, and they constructed stone pillars, or you could call them obelisks. And these things were used to track time by its shadows. As the sun moved, the shadow's length and direction changed, allowing people to divide the day into various segments. And now when the day is divided into various segments, now you get into management and assigning each segment for particular things. So when we fast forward to around 1600 to 1500 BCE, in the Babylonian Empire, they had something we call water clocks. So it's a bowl or container that slowly filled or emptied with water. So you'd think of a system where there is one that is dripping water into a bowl, and this dripping of water changes the level. So the Babylonians could measure time even at night or cloudy days. And this is one of humanity's first continuous clocks. You see, so the previous Egyptian concept was basically fully reliant on the position of the sun and what the sun is doing at a particular time. But the concept of the Babylonian was that for it relied on water, and that meant that this could flow for a long time through even the nights and through the days, and it's not like dependent on the position of the sun. So now when we fast forward to 1500 to 150 to around 100 BCE, the ancient Greeks had developed a mechanism, and it was called an Antikythera mechanism. The Antikythera mechanism was an ancient Greek bronze device, bronze, get me right, with gears. Basically, the first analog computer, if you can say. It predicted eclipses, traced planetary positions, and marked calendar cycles. It showed that humans were building precision time tracking machines. And you must give it to them that this is well over 2000 years ago. It's so into the past. But these people had figured out a system in which they could also tell time, and you will later appreciate all of these frameworks, because ideally may believe they're like foundations for better things that were to come. So mechanical clocks started appearing in the 1200 CE. Clocks were built with gears, springs, escapements, like a part that releases energy in regular beats. They made timekeeping accurate and independent of the sun or water, allowing cities to coordinate schedules and have bells. Then we come to the pendulum clock, and it was invented by Christian Huygens in the year 1656. This clock was a swinging pendulum, and it kept quite a very steady time. It drastically improved accuracy from being off by hours to being off by just a few minutes each day. So when you think of this concept of a pendulum, I think it's very brilliant. A pendulum has this one scientific principle that it doesn't matter where you pull it from or how much energy you use to push it or to initiate its motion. It will always spend the same amount of time. If you use a lot of energy, then it's going to cover a longer distance to get to its point and back to where it started. If you use less energy, it's going to travel slower, going to its destination and coming back to the point where it was released. And that time will always be the same. So this significantly improved the accuracy of time. But this is so into the past. Quite recently, we get the most astounding and I would say one of the biggest discoveries in humankind. And this was Einstein's special relativity, which worked on in 1905. So Einstein's theory was showing that time was not absolute. So initially, all these previous systems, if you've observed when I've been sharing this, all these previous systems had like a similar concept in that time was just the same. They believed the sun was in one position and it was offering the same to all of us wherever we are. But then Einstein shows up and he's like, wait, I think it is not right for us to assume that time is the same at all instances, in all places. So he questioned just that basic principle. And Newton had still built on the previous idea that actually time was absolute, it was true, and it was mathematical and like the same regardless of where you are on Earth. So Einstein comes with this theory of special relativity that talks about dilation of time with velocity. And the theory simply states that the faster you move, the slower time takes for you. So for someone that is moving very fast, say maybe close to the speed of light, this is hypothetical. And if you're comparing that person in relation to someone who is stationary, the person moving close to the speed of light, their time takes much slower than the person who is in a stationary position. And I repeat, these concepts are quite more complex than I might be uttering them out. So this gave birth to a new idea that actually time is also relative. And now it gave birth to the twin paradox. And this was still around that time, 1905. It was introduced with that idea of special relativity. And the twin paradox is just a thought experiment in which you have two twins, each with a clock. So while they're together, both of their clocks are ticking at that exact same time. Then you get one twin to like leave and start traveling at the speed of light, close to the speed of light. When when he makes a round trip and comes back, it is clearly observed that he's older, that the one who stayed on Earth, he's older than the one who traveled and came back, because his time was ticking slower than the twin that stayed stationary on Earth. Then we thought that that was it all. 1915 came, and still Einstein published his second major theory, and this was general relativity. Now, general relativity is very broad in its sense, but we'll pick out that concept that revolves around time. General relativity was trying to bring up the concept that anything that has... Okay, general relativity fundamentally first explained a concept of space-time, in that time and space cannot be put apart. That was the first fundamental thing general relativity explained. Then it later came and said that, but that time and space can behave in a weird way when it is close to something that has like a lot of gravity. So from the basic principles that we know, gravity is simply like that attraction, that force like of attraction that is between two bodies. Now that is a Newtonian definition of gravitation. But then Einstein's theory was trying to explain that actually the fabric is space-time. And when something with a very high mass is in that space-time, it does things that cause the space-time to behave weirdly. Stay with me. You're going to love where this is going. So Einstein's second theory was still trying to say that it was still, when you think of the work he was doing, you do realize that they do have like that naming relativity. So there is some sort of, for example, if you're asking me what is the time, the follow-up would be in relation to what? Because there is the relation of motion, but there's also the relation of how close you are to a point that has an intense gravitational force. So for example, if one clock is placed on top of a mountain and the other is placed at the bottom of that mountain, or like at the heel of that at the foot of that mountain, if initially they were having the exact same time, they're ticking at the exact same time, you'd realize that when they're brought back together, there's going to be a slight change. Now, experiments have actually been done to prove this, though I would not say that it's as easy as I've just stated it. But when the experiments were done, we realized that there had to be a correction of 0.38 seconds in time on the surface of the Earth from the time that is being communicated by satellites outside, or that satellites that are in orbit. Because if that correction was not made, 0.38 seconds seems like, you can negotiate with that. It doesn't seem like a big deal. But in actual sense, it actually means a lot. It could change. Many things would literally not work if that correction was not made. And it was made because one man sat down and discovered that actually the time you experience on the surface of the Earth is not the exact same time that is experienced outside, maybe in orbit of the Earth. And you must give this to Einstein, because by the time he's talking about all of these things, space travel was not even a thought that existed amongst people of that time. Secondly, there was nothing like a space program. There was nothing like a thought that maybe let's put satellites into motion, because the first satellite was set into space some good number of years later, even after the Second World War. But this guy, by just sitting down, he was able to figure out that actually this is the concept and this is how it works. So now, today, we can make those adjustments and have perfect systems. So you're able to order like an Uber and it finds you where you are at the exact time. Because when you're using the internet, your message is firstly transferred to the satellite. Then the satellite has to transfer that to the Uber driver. But remember, there is that concept I've told you of relativity. So naturally, the system autocorrects itself and ensures that your communication is perfectly synced with the person you're trying to get to. So now think about this. I don't know if you've watched the movie Interstellar. In there is this one planet that was revolving around a black hole, and that is actually quite very accurate to what would happen, because black holes are the things that have the greatest gravitational pull. It's so strong that even light itself cannot escape. And you'd think that sounds obvious, but light, you should remember that light has no mass. If it cannot escape something with such a pull, then the thing is definitely very, very strong. So near a black hole, 1 hour for someone that is at a distance, of course this can vary, for someone that is maybe at a good distance could translate to around 7 years on Earth. Just imagine you spend 1 hour close to a black hole, and by the time you get back, 7 years have just elapsed like that. Imagine what you've missed. So now, when we move forward, there are a few things that are changing, that have actually changed over time as we went on understanding and building on previous ideas of what we think time is and how it operates. The LIGO gravitational waves. Let me talk about this. LIGO is a giant laser experiment that detects ripples in space-time caused by a massive event like a black hole collision. When space-time stretches and squeezes, LIGO detects these tiny changes, proving that time and space are dynamic and more of flexible. So remember, from Einstein's theory is stating that time and space are but one intertwined entity. So then fast forward to around 1955, quantum clocks start to come into play. And a quantum clock is simply a clock that uses vibration frequencies of atoms to measure time with extreme precision. This is more accurate. They would only lose about 1 second in the age of the universe if they are being applied to such a task. So these are some of the concept of how time telling has evolved over the years. Now, what is time as a concept? What is time itself? Because that is the question we're asking at the opening of this podcast, of this episode. What exactly is time? So there are very many explanations, like I told you. You cannot call one wrong or the other alone, but they are a perfect blend of something that explains a particular concept about time. And the first one is the arrow of time. This concept was formalized in the 1850s. It's basically the idea that time has a direction. It always flows forward and does not flow backward. And this concept is largely linked to entropy. If you know what entropy is simply the progression from any system from a state of order to a state of disorder. It's like the inevitable path that every system on the earth has to undergo. For example, you get an apple, place it down, and as time passes, it goes bad. And if it's like a time-lapse video, you would watch it go bad and take on different states until it just turns back into soil or something. You get? So that is one of the concepts that try to explain time. Simply that forward transition from order towards disorder. And this is responsible for making the past different from the future. So the other concept that was conceived in around 1908 is the concept of the block universe, a view from physics that past, present, and future all exist simultaneously like pages in a book. In this concept, time does not flow. Instead, we move through a fixed 4-dimensional space. Now let's try to break this down. So the block universe explanation of time simply states that the past, present, and future are but one concept. It's not moving forward, but it is on the same line. So you're basically just jumping from one of those, but they're all always progressing. Think about this. You're born right now. For example, you're 20, and at this moment, while you're listening to this, but in another universe, the block universe, in another block universe, there is a you that is just being born. There is a you that is 15, one that is 7, one that is 2, one that is 3, one that is actually just waking up to have breakfast. So all of those are existing at the same time, simultaneously. So you're just hopping through each of them. That is the block explanation of time. Now there is the emergent time explanation of still this broad concept of time. And this is a more modern idea in quantum gravity, and states that time might not be fundamental. Instead, time arises from deeper timeless physical processes, meaning time could be a product of relationships and interactions, not a basic integrity of reality. So this is one of the modern ones, and it is basically explaining that time is not really an entity that exists or an experience like the others are trying to explain. But this explanation tries to state that time is being produced by our experience. So it's like a road that keeps building. It's like a train track that keeps being constructed one rail ahead of the train. You get? It was never there. So every choice you make is independent, it's new, it has never been done. And you should also remember that this is a very serious topic, and there is still more work being done on trying to understand what this is, because its indications could be substantial. It could explain very many unknown phenomena that is currently happening in the world. There are things that the observations that are made and cannot fully be explained by the models we have, but by the theories that have come forth, they could try to take on some form of explanation. And science fiction has been very good at taking on these adaptations and trying to shape them into an everyday understanding. And partly that is the goal of a stellar insight, is to get broad and complex topics, to bring them to a basic and simple level of understanding. There are many workings that are being done at CERN. There are things that are being done with quantum computing, and all of those are seeking to explain this component of time, because even at different levels, time has different principles. For example, at the quantum level, how does time behave there? Do the things in that world obey the same principles that we obey? We might not know how significant such an idea could be, but we might not know how significant such an idea could be. But when you fast forward, it could have implications that go beyond what we ever imagined. All the investments that are made in science somehow usually yield their profits or results in the future. Someone would have said maybe in the past that do not invest into researching medication or improvement in medication because people are hungry and didn't have what to eat. So maybe someone would say that instead of trying to develop new drugs, why don't you get that money and give it to the hungry? But when you look at what we have right now, I'll repeat, the life expectancy of people has increased drastically. You can look this up, you don't have to believe me. It has improved significantly because you wake up and you're sure that if you get a malaria, there's a drug for it. If you get a flu, there's a drug for it. If you get an infection, there's a drug for it. But in the past, once you got it, it was a death sentence. You were guaranteed to die, even if it was not that dangerous. But the knowledge around these concepts was so minute that it didn't matter. The moment you had it, you just knew, like you say, your last prayer and sign out. But today, people are living longer, and the longer people live, is the more better discoveries are made, is the more better improvements are done in various aspects of time. All fields have changed. And of course, with the rise of artificial intelligence, they're even changing the more and probably faster. The arts are changing. Science is changing. Literature is changing. All of those things are changing. Why? Because of all the efforts that are made, of all the efforts that we make as a society headed towards the good and growth and progression of the human race on the earth. Because none of us has been here before. we are all trying it for the first time. But when we have individuals that can take bold steps and try to question things that no one has questioned, try to look into things that look weird or unreasonable, such people are a gift, and you are a gift as well. So the more you question some of these ideas, the more you think deep on it, you open your mind and you like think out of the box and try to understand or to figure out or to come up with something that tries to explain what you're experiencing. It's in a way a contribution to humanity as a whole. I don't know if you get what I'm saying. Now, the Bible, of course, has an explanation of what time is. And I think a beautiful one is the concept that the Creator looks down on time as a block universe, like the way the block universe explains it, that to him, the present, the past, and the future are but one. So he sees them in one full chunk. And there's always that question of how did God create time? When did God create time, rather? That I think sounds even better. And I think the answer to that question is within the question that if God was the entity to create time, but was still bound and limited by time, then it wasn't worth being God in the first place, you know? So when you think of it, is like this entity that sees from outside and he sets the pieces right. I personally have a very construed concept when it comes to destiny, because whenever you talk about time and God, the next thing is destiny. Is everyone where they are? Is everyone meant to be a certain thing? No one is meant to be a certain thing. I believe that everything works under the principle of cause and effect. And this is very clear through the Bible. Whatever everyone does always resulted into something. Whether it was righteous or unrighteous, it always had a certain consequence, because something has to interact in order to have a result. So many of the things that we are headed to, many of the things we are in right now is where we are supposed to be. I believe in that. But not everyone at the onset is headed to where they're supposed to head. So you'd say that, oh, how about those that are maybe disabled? Were they meant to be in that state? That is a bit tricky to answer. But I do believe that if our God is as big and loving as he is, of which he is, as loving as he says he is, of which he is, then no one is meant for suffering. But as I told you, everything has a cause, something that causes it, and then the effect of it. Maybe something went wrong in that baby's fetal development. And this is the gift of science, that once we understand some of those things, we can prevent certain things from happening. For example, the work that is being done with gene editing. There are cases where they can predict the outcome of that child, and it's 100% like the child will be born with this and this, for example, sickle cell. But if the science to solve that problem develops and that baby's situation is fixed even before they are born, there won't be a cause, then there won't be an effect, and then we won't question the sovereignty of God because of that. I hope you get what I'm saying. So there is still a chance besides hope, even, of which hope is one of the greatest gifts that we've ever received. But there is still hope, even. There is still a chance besides even hope to fix some of the things that seemed impossible in the previous era. If you went back and told people that influenza that murdered millions of people, today someone just sneezes it off in the morning and goes to work and totally nothing happens to them, get a few tablets and they never even get a break, they might not believe you. There are very many other concepts. If you tell people the speed at which we are traveling these days, it sounds like science fiction in a way. But I also think that is a gift from God, that we're able to experience this, that if we move fast, time will slow for us, so that we experience more and do more and sort of set a platform for those that are to come ahead of us, that they live a better life, because I don't think those that were before us wanted to live a broken world for us. It is more of an innate character in humans to always secure to always leave a secure environment for their offsprings. Mostly, not even just humans, but most of the creatures that we see around. So I think I'll do a few questions, maybe like two. The obvious question is, so now that we are getting to understand time, is time travel possible? If it's possible, then what are the constraints? I'll say time travel is possible, but not the understanding, for example, that the arts have painted. You could travel into the future. For example, I told you, if you, for example, got into a spaceship that travels close to the speed of light to go make like a rotation around the nearest star, by the time you come back, a few thousand years would have passed on there, and you will have aged maybe a few months or even just a few hours. There are concepts that explain each of this. It's not just a man's idea that if you do this, this should happen. No, there are deeper concepts that explain this. So you'd say in that way that time travel to the future is possible. But also, the question now comes to, is time travel to the past actually possible? I would say we don't have very strong evidence that prohibits it, but still there is no strong evidence that promotes it. The understanding of these things that we have do not permit. You never know, maybe it could be figured out in the near future and we use it to correct certain things. For example, what if it's used in solving crime? That could bring it down significantly. A crime happens, then like the government has the ability just to rewind and fix everything. It could have a lot of benefits if you think about it. But right now it is still skeptical. Thank you for joining A Stellar Insight. Today we've covered time. The question we're asking, what is time? Have we gotten the answer? Somehow. And do we still think we have a chance to know what really time is? Yes, we still have a chance to know what really time is. We've just explored the different concepts that explain this complex thing called time. Thank you so much for joining. If you have a thought about what we've talked about, you can leave it down in the comment section. And thank you. And next time we meet, we shall be talking about quantum computers. I think it's a very good topic, and this is a very good season for us to explore that concept. And until next time, thank you. Stay curious, stay questioning even the most obvious things. I say now.